Thank you, everyone, for joining. My name is Nathan Miller. I'm the founder and CEO of Proving Ground. I'm joined by Nicole Mader, who is our Director of Product. And we will be talking today about the latest developments in Conveyor. As of today, Conveyor version 4 went live on our website, so it's available for trial and download. And so we're excited to kind of preview some of these new features in this webinar and answer any questions that you may have. A little bit of background and the usual stuff that you typically have to cover when you're promoting a product and or a company. Conveyor is authored by Proving Ground. We are a digital design agency based in the United States. And we help architects, construction companies, engineers, and building owners make use of their data and take advantage of the wide array of technology that is at our disposal today. And the story of Conveyor is really one about developing efficient workflows between two popular applications, Rhino and Revit. And this sort of study has, I guess exploration really goes back many years in kind of my career. When I was first working in the world of design as an architect, and I really wanted to find different ways of making use of my geometry and data as I was designing in Rhino. And also satisfy the requirements of a project as it was being delivered in Revit. And if you rewind the clock, maybe 14 years ago now, maybe even longer, and think about where we have been, the level of integration has been a persistent challenge within the industry. And we know that in my opinion, Rhino is a phenomenal design tool, and it's only grown in popularity over the years. And Revit still kind of maintains, I guess, a market presence as the dominant building information modeling platform. So, kind of seeing these two applications fit together, share geometry, share data, has been I guess, an important part of developing meaningful workflows for the design and construction industry. As I proceed through this presentation, feel free to ask questions in the webinar chat or the Q&A box, and Nicole will try to respond to them as they come in. And if there are any questions that are outstanding or require further elaboration, we can maybe have a discussion about them as we get into the meat here. So Conveyor addresses a very, I guess, basic premise here. It's just we understand that the building design and construction industry is complex. There's a lot of air traffic control, if you will, needed to manage the flow of information among a very kind of decentralized information landscape that it makes up the building design and construction industry. And if we were to kind of look at Conveyor as a component to that, we wanted to design a toolkit that just kind of tries to simplify as much of that process as possible, both from a setup perspective, but also from a skill set requirement perspective, and from a kind of from the perspective of having the tool work within proven project workflows. So if I look at, I guess, some of the guiding principles of how we've gone about developing Conveyor in the last, I would say 6 years. It's been a product that you can download for 3 years, but we've been really developing it for the life cycle of Proving Ground, about 6-7 years now. The toolkit works in the context of no need for servers or cloud services. We know that those are quite fashionable to have as sort of central to the several workflow management schemes that are out there right now. We're really interested in just the direct integration of these tools. So they're desktop plugins, and they enable a direct connection between the Rhino and Revit environments. From a skill set perspective, we also know that people that need to take advantage of these workflows oftentimes don't have computational design skills at their disposal. Maybe their skill set lies elsewhere, but they still need to be able to transfer information between these different systems. And it's in many cases, there's been a trend to say like, oh, well, we can connect Grasshopper and Dynamo or Grasshopper and Revit directly. We wanted to kind of enable a user experience that was really based around the direct modeling approach, i.e., if you can model things using conventional modeling techniques in Rhino and manage things using conventional management techniques in Revit, we wanted to have Conveyor kind of situate itself within that paradigm to allow for easy and simple but powerful workflows. And the toolkit really did evolve out of the project workflow scenario. And just to kind of take you through a few projects here that we're really proud of being a part of that leveraged early versions of this technology to the point where we're now finally seeing built work come out of it. I wanted to highlight a few updates here. This is the Gilder Center for Science, Education, Innovation. I believe it's very close to opening in New York City as part of the American Museum of Natural History. Studio Gang developed a very elaborate and complex interior made up of very organic geometry. And I think if you look at the history of various CAD plugins out there, I feel like this may have been one of the last major projects out there to use T-splines before that product got retired. So there was a lot of cool subdivision modeling taking place. And when we were developing workflows in what would eventually become Conveyor, we built in a lot of tools that would allow for the translation of very complicated mesh geometry and BREP geometry in general, such that information from Rhino could be integrated into Revit for construction documents with clean cutting and the ability to have this geometry represented in document sheets for the project. There was also quite a bit of development around panelization and supporting more complicated facades that was born out of this project exploration. And then similarly, a project that is very much well underway in construction at the moment and slated to open in, I think now 2025, is the Lucas Museum of Narrative Art. And for me personally, I was really excited to work on this project because of my affinity for all things Star Wars and science fiction, and the tie to George Lucas is extremely exciting. And we were brought in by Stantec, which is who is the architect of record on this project. They partnered with MAD, who is the design architect. And we implemented a set of workflows that allowed for this kind of project management to occur with the complex geometry, from exterior paneling systems to some of the development of landscape design to a number of the interior spaces, and the kind of translation of geometry and data between the Rhino and Revit platforms were instrumental. And now we're kind of seeing the results of that occurring, having occurred by way of these very powerful construction photos. And on a monthly basis, I feel very fortunate to be able to see 360 walkthroughs of the site. And we can start to see how some of those geometries that we became very intimately familiar with are making their way onto the project. So that kind of leads into just the, I guess, the various paradigms that Conveyor supports, and some of the new workflows that are available in Conveyor V4. So as of this moment, Conveyor supports two types of workflow paradigms. One is kind of based around an import workflow, wherein if you have a Rhino file, you can import selective elements into Revit using I guess a user interface that lets you select the file, select various elements, and then bring them over without having to open up Rhino, and even without requiring a Rhino license. We were able to use Rhino's open NURBS file format and extract information and recompose it in Revit using the Conveyor platform. We also are able to use an interactive workflow, which is built on top of the pathways established through Rhino inside Revit. Now, Rhino inside Revit is a very, I would say, popular interoperability scheme that allows Grasshopper to run inside of the Revit environment. And you can do all sorts of things with this platform. What we're able to do with Conveyor is Conveyor can sit within this scheme, and you can then start to use Rhino's direct modeling interfaces, and then use Conveyor to do one-click transfers of objects as you model them without the need to touch any of the Grasshopper components. So it adds another level of a very simple integration to the workflow. So the kind of basic philosophy of the platform of this toolkit is really about how you start to map geometric elements and components to building information modeling definitions. And that's really the challenge of this kind of interoperability and integration between Rhino and Revit. It's the idea that within Rhino, you have a model anything type of philosophy, and you're working with raw geometry most of the time. And you have to, in order to get that over into Revit, start to prescribe meaningful categorizations and definitions for what those objects represent. So if you have a surface, that surface could be a wall, it could be a floor, it could be a facade element, or maybe a more of a specialty feature within the design. And so there needs to be this way of classifying this this workflow and these geometries for the workflow. And so what Conveyor does is it provides a user experience for mapping those types of definitions such that when the element is created in Revit, it has associations that are available to the user and are made possible by the Revit API. Which is quite extensive, but also does have various limitations. So anyone that's worked with the Revit API kind of knows that, that there are boundaries with which you can do things. You can bend the rules of Revit, but not necessarily break them entirely. And so we're kind of operating within that space to achieve these mappings. And so, what you find with Conveyor is this kind of system of categorization. So you might have this poly surface in Rhino, and you need to be able to say, okay, what is this poly surface actually when it comes to the classification of Revit objects. And with Conveyor V4, we've expanded on this. So you can see here you have this ability to, import component families. There's, kind of mass-based curtain systems, floors, roofs, structural framing members, and there's all sorts of subcategories within that. One of the things that we've made possible with Conveyor V4 is the ability to bring over curtain wall grids. And if I can get the video to play here. There we go. So in past versions of Conveyor, we could bring over walls. And one of the things that we've been hearing from users of many different types of platforms that are dealing with integration is the ability to bring over curtain wall grids and have them assigned to the objects. And so here, what we're able to do is we're able to define horizontal and vertical curtain wall grids, very standard and we have this ability then to generate native curtain wall elements with mullions that are editable, or grids that can be reassigned to different types. And so the resultant workflow here are native objects, wall objects that have the mullion grid datum. And the user has options of kind of auto assigning a default mullion scheme to the grid, or you can leave the grid alone and then assign mullions of your choosing after the import. And we saw this as kind of a gap to fill, and we thought that Conveyor offered I guess a structure that would allow for these types of elements to kind of fit within the workflow paradigm that we've established in subsequent or previous versions of Conveyor V3 and V2, et cetera. Another thing that we've heard from our customers and our clients is the support for blocks. Now, Conveyor has supported blocks for a while, Rhino blocks, as in collections of object geometry. But what many people do when they're creating blocks in Rhino is that they use nested block elements. So you might have a block that is then made up of a variety of other blocks. And that was something that we wanted to fully support by enabling a geometry transfer that would allow for blocks that contained nested block elements to come over. So what we did as a test here is one area that we see people grabbing 3D geometry from is the SketchUp 3D warehouse, which has just a whole slew of different things. And when you bring a SketchUp object into Rhino, you end up with block elements and nested block elements and things like that. So we wanted to see like how could we basically take some of these kind of assemblies that have very deep, some cases very detailed geometry with subcomponents, et cetera, and make sure that this is supported through the workflow. So what you're seeing here is a set of blocks that have numerous nested components and layers and other block definitions within. And what we're going to do here is we're going to go into Conveyor and we're going to load those elements in. And what is going to happen is Conveyor is going to drill down into the block definitions and pull out and reconstruct the nested geometry in a single Revit family. So what you have here are Revit families that have the nested components brought in. And another kind of thing to note here is that this is also supporting mesh-based transfer. So the underlying geometry in some of these cases are mesh-driven, and those are being dropped into a Revit family, and further, allowing for certain types of geometries to be supported across these platforms. Going on to the next slide here. Another area that we kind of expanded support around was this concept of materials. And in previous versions of Conveyor, if you were to transfer a B-rep over or a polysurface over a block that's made up of polysurfaces, what Conveyor would try to do is it would search the Revit library for materials that match the Rhino material assignment. So if you had an object inside of Rhino that was, say, the material color yellow or something like that, the material name was yellow, it would sort of jump over into Revit and say like, oh, is there a material named yellow here? And let's grab it. And if there wasn't a material, it really wouldn't do anything. It would kind of create a blank entry on your object. What we've done in Conveyor V4 is introduced this idea of transferring basic material properties from Rhino and creating the Revit materials if they don't exist. So what that allows us to do then is say, if we have this, in this case, a kind of a fun Rubik's Cube model that has a number of different colors, colored materials created inside of Rhino, what we can do then is have those materials transfer over with the object itself and have them assigned to the Revit, the resultant Revit object. And so what you're seeing here is the families being created, and the material that came from Rhino also being created in the background in Revit and then assigned to the object. And those become, for these families, a set of editable properties that you can, if you wanted to change the material or edit the material, you're free to do so. And we kind of see this as an important step forward for supporting, things like visualization, rendering, and also kind of even further tightening the level of integration that can exist between these two platforms. A couple of things that have happened on the Rhino Inside integration that we've built via Conveyor that we think is pretty exciting. We wanted to figure out ways of having kind of a more dynamic back and forth user experience for some of the kind of common element types that people are engaged in. And so in version 2 of Conveyor, we first introduced the idea that Conveyor could be launched through Rhino as Rhino is operated, or as Rhino may have been launched through Rhino Inside. So that means kind of this ability to sort of click on an element and then through Conveyor hit send to Revit. Or if you're in Revit, you could click on a Revit object and say, send it over to Rhino. What that kind of produced was this type of workflow where you can, select a number of different elements. You have Rhino and Revit operating in parallel, and the Revit objects are created from that Rhino-based information. No Grasshopper use is being implemented here. It's a very sort of simple workflow that if you know how to select elements and click send, that's the sort of basic premise, right? So what we want to do is build on that a little bit and say, like, well, what if a user needed to send over, say, a collection of floors to Revit, and then they made a few edits to those floors in the Revit side? Could you then pull back some of that geometry that's been edited back into Revit or back into Rhino, and kind of have this kind of push-pull type of workflow? And so we've introduced a level of dynamic updating that's occurring here, wherein we can create in this case, we're using floors. We can create a collection of floors in Revit. We can then edit those floor profiles. We create an opening in those floors or edit some of the boundary conditions, and then say, okay, well, now I want to bring that edited floor back into the Rhino world. And we can do now what's called a dynamic update, which will find that previous floor and then recompose it using the updated Revit geometry. Then we can continue working on it. So let's say you're now going in and editing the boundary condition of the newly updated floor that just came in from Revit. We're going to go through that process here. And then we're going to say, okay, I'm going to now select this updated Rhino floor and then send that back into Revit. So can start to envision that there may be some of these really powerful push-pull capabilities through this interface that we're pretty excited by. In version 4, we're supporting floors, grids, levels, and structural framing elements as being part of this paradigm, and we will be kind of expanding those element types as it becomes feasible to do so. Floors are a very good use case for this because of how the mapping of raw Revit or Rhino geometry works in the context of Revit and vice versa. So there's a kind of a nice way to parallel this and track updates across the platforms. As another example of this, let's see if I got the next slide up, includes this sort of, this is a structural framing example of the same type of concept, wherein here are some center lines that are defined in Rhino, and those are then driving the creation of native structural framing members inside of Revit. And if I, as you'll see here, what I'm doing is I'm kind of pulling those members and adjusting the lengths and maybe making that opening that's being defined by these structures a little bit bigger. And so what I can do then is select those objects that have been changed and then do a dynamic update, which will then update the center lines inside of Rhino. So you're, again, doing that kind of push-pull operation, almost kind of treating Rhino as a wireframe sketch, which then drives intelligent building information modeling elements, and then changes to the building information modeling elements can then kind of go back and transform the sketch using this dynamic update capability. And just as a bit of a recap about some of these integrations, the ability to kind of go back and forth and the kind of previous features that have been introduced in Conveyor are still kind of all very much present and preserved. So if you're using workflows that you're used to and comfortable with, those are still present. This is an example of features that have been introduced in the past for not only converting objects over into Revit, or from Revit into Rhino, but also showing that material object properties and parameter information is being transferred over as well. And then as we kind of go forward here, this is kind of where Conveyor V3 left off, wherein we're bringing over block elements and direct shapes with materials being mapped over to them. So we're creating these kind of more sophisticated assemblies and family components and direct shapes using the transfer protocol. But to kind of recap this idea of nested blocks, this is kind of the Rhino, the kind of interactive mode here, wherein you might have block assemblies that are nested within other blocks, et cetera, and then we're able to kind of build on that previous V3 workflow and say, let's load those all into Revit and have them all represented with not only the nested elements included, but also materials that have been assigned to those nested elements. And then those materials themselves can then be edited as well when they're brought over. So let's see what else we have here. So upgrades and perpetual licenses. One of the things about Conveyor that I think, I don't know, maybe we're very old-fashioned when it comes to how we sell software. You don't really see this very often, but we do sell Conveyor as a perpetual license type of tool. So there is a perpetual license for Conveyor V4 that you can purchase and download, and those licenses don't expire, they don't renew. It's a one-time cost. And then if you want to upgrade, we provide our kind of current customers an upgrade discount to new versions. So it's kind of on you to upgrade as you see fit. We certainly have customers that are probably still plugging away using Conveyor version 1 after 3 years, which is pretty cool to see, and same with Conveyor V2 and V3. And so if you find the kind of development trajectory appealing between versions of Conveyor, we offer discounted upgrades. And as of right now, those discounted upgrades are available to current users, and new perpetual licenses are available as well for purchase of V4. We have a number of enterprise subscription-based agreements with companies that want a more kind of flexible licensing scheme. So if you're interested in the kind of single cost to support your entire organization, we're more than happy to work with you and get that set up. And when you're on kind of an enterprise plan with us, all of these upgrades for different versions of Conveyor are included as part of your agreement there, along with support and in training and other kinds of things that we see as important for supporting a firm's implementation of these tools. And finally, if you are a student or an educator, we provide discounts on these products to make them affordable and accessible to the academic community and the research community. So if you're a student, you can get an 80% discount on any of our products, Conveyor being the focus of this presentation, but we also offer various integrations with Semantic and Tracer that allow you to take advantage of data, visualize information, and tie these 3D models into the world of business intelligence. Those are all there from an educational discount perspective. So if you're a student, feel free to reach out to us. To just take you on a quick tour of the resources that we have. This is the PG Apps website. We have Conveyor, Semantic, and Tracer that you can explore. You can get access to now a 30-day trial of Conveyor. So we've extended the trial period for Conveyor. So we're excited to have our users try that out. So you can go to the website and try or buy the product. The version of Conveyor, version 4, will include a free upgrade to Revit 2024 when that releases this spring. We're anticipating that coming out here in April, and usually we put out updates to plugins within a month or two of a major Revit version release. So you, as a customer of V4, can expect to see an upgrade to the next annual release of Revit as well. We have a number of new documentation resources in support of V4. Nicole has worked diligently to put together a new set of video tutorials for Conveyor V4, covering the workflow for dynamic updating, the workflows for curtain walls and grid lines and mullions, and nested blocks of materials and materials are all here. We're very adamant about documentation as being an important part of a product's user experience. So we're always adding new video tutorials and expanding on the documentation, even frequently asked questions and troubleshooting guides if you're having a problem are things that we're always kind of adding to and expanding here. Because ultimately we want our customers to feel like they can get access to resources that help them use the product and be better with the product. So feel free to check this out. And these are all kind of roped into the overall product experience that we've been designing and developing here. So with that, if there are any questions or anything that might be worth expanding on, I'm more than happy to have a conversation about.
I can direct you to just a couple of questions in our Q&A chat. Philip is wondering, can you explain how to connect Rhino floors and Revit level information?
Oh, sure. So the way that works, and maybe what I'll do here is I'll just use our documentation resource as an example of this. So if I go to the Convert a Floor resource here in our documentation, you'll see that there are a number of ways with which floors can be imported. And if I go to import a floor with a Revit type, what happens is that you inside of Rhino are able to define a floor boundary and give it a floor type. And then what happens when it comes into the world of Revit is that Conveyor will look for the nearest level that floor exists on, and it will then host the floor to that nearest level. So what you kind of see here in this animated GIF is that there have been a number of levels already kind of brought in, and these floors are then imported in, and they're mapped to that nearest level. So there is an element of, especially when it comes to floors and levels, kind of a hosting component there. So then if you were to be in Revit and move one of those levels up, the floor would be attached to it and go with it.
There's another question. Can the panels within the curtain wall system in Revit be replaced with a curtain wall block from Rhino using Conveyor?
Not exactly. So again, like the approach is that we can bend the rules of Revit, but we can't like break the rules of Revit. So if you were to like create a curtain wall, if you were to create a block and bring it over, that block is likely going to be like a generic model or some specialty equipment or some other classified component family. But so you wouldn't be able to sort of say like, okay, take this curtain wall panel out and put a block in its place. I mean, you could. It wouldn't be like hosted to the curtain wall system. I mean, you theoretically you could kind of maybe delete a panel out, and then kind of in place put one of the families that have been imported. That's certainly a possibility, but it's kind of a level of it's kind of a bit of a workaround, right? What you can do is like when the curtain wall has been created, you can certainly change the panel types of the curtain wall, and go through a normal Revit-based workflow for editing that curtain wall after it's been imported. So if you wanted to swap out a panel type for another curtain panel type that you may have loaded in your model, you could do that.
That covers all of the questions in the Q&A.
I
encourage anybody. Oh, go ahead.
I do see one question that may be worth responding to as a follow-on. Kono, does the curtain wall workflow allow the user to identify which mullion families are being used? The workflow as it is offers two options. You can bring the curtain wall grid in without a mullion assigned, or you can do a kind of a blanket application of the default mullion type in the Revit model. We could, I suppose, offer an opportunity to where you would be able to specify the type of curtain wall mullion, but that may be a future exploration that we would want to do.
There's a new one from Philip in the Q&A if you want to take that.
Oh, okay. Can we use multiple linked Rhino models with a single central Revit model? Just wonder how to save and reconnect back to the Revit model. That's a great question. So you are able to, there's no limit to how many Rhino kind of documents you may be using at any given point in time. So for example, if I open up, let's see if I can get into Revit here. There is the possibility, for example, to say like, okay, let's say I'm using this model and I bring in a number of different workflow element objects over into the Revit world. I could, you work on this model for a while, and I'm then, importing into the Revit model here. So this model, this open Revit document is, could be a central model, sure. So I'm bringing elements over from this document, then I could open up another Rhino document, or if I'm using linked Rhino files in a work session, activate one of those other files in the work session, and then transfer objects over there. In fact, last year, Nicole and I ran a tutorial session webinar where we did exactly that. We structured a project. In fact, let me go see if I have it. I think we have it sitting in our documentation here. So if I go to video tutorials, on our website, and we have a recorded live workshop section. Yeah, from March 2022, we have the workshop data set. This may be a really good one to drill into, Philip, because what we have here is a scenario where we had multiple Rhino models linked together via a work session. And then we used Conveyor to bring over elements from the various Rhino models through the work session, and then progressively brought them over to a single Revit file. So it became as much about learning about the different workflow techniques available in Conveyor as it was about learning a possible model management strategy for a complicated building structure and assembly that's made up of multiple different types of files. So presently, there is a question about upgrades. Presently the upgrade is from V3 to V4. And that's typically what we offer when it comes to the upgrade discount opportunities. It's sort of like version to version. But if you have like a very old version of Conveyor, there's not an upgrade path for those. At that point becomes economical to buy a new license. Is it possible to transfer geometry to Rhino from linked Revit models? One example is working with our Revit model where the CS is separate. Oh, I see. Yeah. So if you are working in, so this is a bit of a, this is kind of a limitation of, if you have linked models inside of Revit, those model elements aren't accessible to the workflow unless you activate one of those models. So if you were to like bring over some of the geometry, if you wanted to bring over some of those geometry from a linked model, you need to make that linked model the active document in Revit for you to then be able to access the objects and its properties in order to transfer over to Rhino. Hey, thanks, Lewis. Lewis said thanks for the presentation and the development of the plugin. Always appreciated, Lewis. Good to hear from you. Which Revit versions is Conveyor compatible with? Was a question from Wesley. The version of Conveyor V4 we are making compatible with Revit 2021, 2022, 2023, and then 2024 when it's released. So our normal cadence as we release new versions is to support the newest version of Revit for that year, and then 3 versions back. So the newest version of Revit for this year will be 2024, and we are then supporting 3 versions back from that. Philip, as another question here, do you offer training sessions for a company if we purchase a license? We do offer training as a service that we provide. There are 2 possible pathways to this. You can, if your company is set up under one of our enterprise agreements, meaning that you want your company to have access to this tool at scale across different teams, across different individuals without getting into perpetual license management. As part of those agreements, we include onboarding training for your firm, as well as kind of more dedicated support as needed, advising on maybe a workflow project, things like that. Now, if you've picked up a handful of perpetual licenses, we do offer training via our consulting. So Proving Ground at its core is a services company, and we do offer various training and knowledge-based services for these types of activities. So, for example, you can get access to Rhino and Revit workflow training with Conveyor, leveraging Rhino data with Semantic, analyzing Revit data with Power BI and Tracer. Those are available types of training that we provide. We've also done some kind of more nuanced training around SQL and just general data management concepts for companies. And those are things that we'd be interested in talking with individuals about. If we're being brought in to sort of support a project, we oftentimes will then provide levels of training for the project team. So there were workshops, for example, for the Lucas Museum of Narrative Art, as well as the Gilder Center team, Studio Gang team, as part of our services there as we were implementing some of these technologies. Are those trainings in-house trainings or online sessions? I'll be quite honest, we have not been asked to do an in-person training in an office for about 3 years now. And I think the reasons for that are very obvious. When the pandemic occurred in 2020, we went full virtual on basically every single service that we've offered. And we have been running workshops and strategy sessions and various forms of training virtually ever since. And we, with rare exception, have been asked to come into an office. But if you're interested in having us come to your office, we're more than happy to do it. I think what one of the things that companies have realized, many companies have realized, is that they can get effective training virtually without having to pay airfare and hoteling and per diem costs. But there certainly is an argument to be made that in-person training can still be quite valuable. But our online sessions are live, they're interactive, and if you're not tired of hearing my voice on this webinar, you certainly would be tired of hearing it by the end of a set of virtual online training sessions. Alexis has asked, do material texture images also transfer into Revit? At this point, no. The basic material properties that come over at the moment are color and transparency, and that's being captured from the Rhino settings that are immediately available. When you start to get into material maps, that's another order of magnitude of transfer and setup that we'd have to maybe continue exploring. But you can certainly add the texture map to the material afterwards to ensure that it's meeting the requirement when you visually when you see it in Revit. If there are no other questions, we have about 10 minutes to the top of the hour. I think we can maybe adjourn this session. I just wanted to reiterate and say thank you to everyone that has attended. This session was recorded, so you can expect to see this recording of this webinar appear online and available through our documentation, and there will be an email announcement that's sent out when this recording is available. So you're all free to rewatch, share around, and if you happen to sign up for the webinar and weren't able to make it today, you'll have access to that recording as well. Thank you very much. We hope to hear from you soon, and we hope you enjoy exploring what's possible with Conveyor version 4.